Hi, I'm Amaya Perry, and this is Chandler Dennis, author of Hollywood Physics and physics teacher in the STEM department of Columbia High School, as well as my grandfather.
Hey, Amaya. Why are we here today?
Today we are here to learn about exponential growth and how it is used in physics.
Okay. Ordinarily, when you talk about graphing things, you've been talking about a straight line. Y is equal to mx plus b. In nature, we have a lot of things which are exponential, and what it means in that is that it increases very quickly. You have on your calculators the button ln, capital Ln, and you see next to that all the time e to the x power. It's an exponent. The number e is an irrational number, much like pi. What's pi?
3.14.
Okay. The irrational number e is Euler's number, and it's 2.71. And you can see this on your calculators most of the time. What I'm going to do is turn it on. I'm going to put in a 1 on this particular calculator, and then I hit second function in that, and we get 2.7. If I put in 2, now remember, it's going to get quick fast. So it's going from 2.7 to 7.3. And let's do one more real quick. If we do 3 e to the third power, it's 20. It gets real quick, real fast. So how is this used in physics? If you've ever heard feedback in a microphone someplace, feedback where the electronic signal is being processed right back and reverberates, okay? That's the situation. Nuclear fission, which goes on in a nuclear reactor, or more precisely, in a nuclear bomb. Let's take a look at what we're talking about, nuclear fission. We use uranium-238, and in the uranium-238, this little graph is showing neutron comes in. You know about that nucleus are made of nuclei are made up of neutrons and protons. We have one neutron coming in. It strikes this nucleus. They split apart, and you get a bunch more coming out that hit other ones and split apart. When they split apart, energy is released. In a nuclear bomb, there's that heat, there's that blast of radiation, there's that big cloud, and there's a destructive capacity. Each of these neutrons gets more neutrons created. So that's a nuclear reaction. That's a positive exponential growth in physics. The most spectacular one we can talk about. Any other questions?
No, thank you.
My pleasure.